Welcome class 10th for chemistry lecture. By the grace of Almighty, hope all are good, staying safe at home. Well, my dear students, in previous two videos of chapter 2, that is part 1, we discussed about electrovalent bond. In part 2, we have done covalent bond. Hope all of you have practiced electron dot structure of electrovalent compounds and covalent compounds. That is given on page number 28 and 29. That is electrovalent compounds are given and covalent compounds are also given. So hope all of you have practiced all these structures. And today in this video chapter 2 part 3 we are going to do third type of chemical bond, that is coordinate bond, which is also known as dative bond. The bond formed between two atoms by sharing of pair of electrons provided entirely by one of the combining atoms but shared by both is called coordinate bond. And what are the conditions for the formation of coordinate bond? One of the two atoms must have at least one lone pair of electrons. Second, another atom should be short of at least a lone pair of electrons. Now, the question is, what is lone pair of electrons? A pair of electrons which is not shared with any other atom is known as lone pair. This is a very important definition, so pay concentration here. Now, example, ammonia. The structure of ammonia you might have done in covalent compound. It's a covalent compound. There is a sharing of electrons. So this you have done in covalent compounds. So nitrogen, ammonia contains nitrogen and hydrogen. Nitrogen atomic number is 7. So configuration is 2, 5. And in ammonia, just see there are 3 hydrogen atoms are there. So each hydrogen atom has one electron in its outermost shell. So nitrogen is having 5 valence electrons. So in this structure, look at here, I have shown this dot, dark dot, that is the 5 valence electrons of the nitrogen, and this cross is shown hydrogen atom. So in the nitrogen there are 5 valence electron and 3 hydrogen atoms sharing 1 electrons by the hydrogen, this nitrogen, and there is one lone pair. This is a one lone pair present in the ammonia. So as I said, a pair of electron which is not shared with any other atom, so that is known as a lone pair. And this lone pair of electron is provided to other atom for the formation of coordinate bond. As I said here, for the formation of the coordinate bond, one of the atom must have at least one lone pair of electron and another atom should be short of at least one lone pair of electron. So this lone pair of electron is now shared, and before that just note down, a coordinate bond has properties of both covalent and ionic bond, and it is called co-ionic bond. That is covalent, ionic, that is ionic bond. That is why it has the properties of both covalent and ionic. So in a coordinate bond there is one donor. What is donor? The atom which provides an electron pair for the formation of coordinate bond, as I have shown here in the ammonia. So this compound, it is having a one lone pair. So this ammonia is a donor and one is acceptor. The atom or ion sharing the donated pair, electron pair, is an acceptor. And coordinate bond is represented by this sign. Just pay concentration. And the formation of ammonia, from formation of ammonium ion, I am going to show you the example, that is the formation of coordinate bond in the ammonium ion. So look at it. First see, this is ammonia, structure of ammonia this side. Same I have drawn here. These two are the same. So see, one lone pair is there. So this is donor. This ammonia is donor. And when this hydrogen ion, that is proton, remember this hydrogen ion has no electron in its outermost shell. This is hydrogen ion has no electron in outermost shell. And when this electron is lone pair is shared, pay concentration, this lone pair is shared by this proton, that is hydrogen ion. So this is a formation of ammonium ion. It can also be shown like this. So once again see this. I have drawn this. This is ammonia. Dot is representing the hydrogen nitrogen electron, and cross is for the hydrogen. This is a lone pair which is shared by this proton here. Or you can show the structure of ammonium ion like this also. So this shared electron is shown by this covalent bond. And this lone pair which is shared by this proton, and see, this is a coordinate bond, arrowhead. It is represented by arrowhead. So this is a coordinate bond. So lone pair of electron of nitrogen atom is shared by hydrogen ion, and thus it acquires the helium configuration, so which is a stable. So hydrogen ion now become the helium configuration, acquires the helium configuration. This bond which is formed between the nitrogen atom in ammonia and the hydrogen atom is a coordinate bond. Similarly, formation of hydronium ion. The hydrogen ion adds onto one of the two lone pairs of electron of oxygen atom of water molecule, forming coordinate bond. Now look at this structure, water. In the structure of the water, there are two lone pairs. In ammonia, one lone pair is there, but in water, there is two lone pairs are there. So when this, now see this water molecule, structure of water molecule, when hydrogen ion is added, what happened? That is proton is added. This one of the lone pair is shared by this hydrogen ion or the proton. So this is a formation of hydronium ion, which can also be represented like this. So these are two covalent bond, and this is coordinate bond. Here the lone pair is shared by this hydrogen ion, that is proton. So this is the formation of hydronium ion. So remember, in ammonia there is one lone pair, in water molecule there are two lone pair. So in this, one of the lone pair is shared by this proton. So this is the formation of hydronium ion, that is from the water to hydronium ion and from the ammonia to ammonium ion. So do practice these two structures. And also one more structure is given, the formation of the hydroxyl ion. You do practice, that is given on page number 34 in your book. So kindly do the practice of formation of this hydroxyl ion also. And don't forget to draw it on your notebook. Clearly mark dot or cross for the two different electrons, showing the electrons for the two different atoms. Thank you.